Okay, so what we did previously was we learned how to state the possible rational zeros or roots or solutions, whatever you want to call them, for each function. Now, when we're talking about zeros, that means x-intercepts. But we're going to list all the possible ones first using the rational root theorem, which says that my possible roots come from plus or minus factors of 4. So what numbers go into 4?
1, 2.
I should say, so I'm going to say factors of 4 over factors of 3. So it's this number and this number. And so we're thinking factors of 4, that's 1, 2, and 4. And for 3, that's just 1 and 3. I don't know why I put a comma before the 1. Let's take that out. So I could do 1 over plus or minus 1 over 1, which is just 1, plus or minus 2 over 1, plus or minus 4 over 1. So I did all of these over 1, and then I can do all of these over 3. So plus or minus 1/3, plus or minus 2/3, and plus or minus 4/3. And then you can simplify things. This would just be 1. You can just change that to 1, and that to 2, and that to 4. So if you count the positive and negative every number, there's 12 possible rational roots. Now, back in the old days, as I was just telling some people, we would have to try each of these roots, which there might be 12 of them, in the synthetic division formula and see which ones divide evenly, and there's lots and lots of work. What we're going to do, though, because we have graphing calculators, is graph the function and use that to find our roots. Now, I have been asked in the past, why don't we just graph it and see what it is? On some of these fractions, like 4/3, it comes out weird, you get a strange decimal, and so this just narrows it down so we know what we're looking at. Okay, so to graph things, we go into the y equals menu, and if there's anything in there, you want to clear it out, and you want to make sure that all of your plots are turned off. So none of this is highlighted, you just got a blank slate. And we're going to put in the original function, so 3, and then this is your x key right here. You people using the alpha keys are making this hard. This is x to the 3rd. And then you right arrow to get out of that, minus 4x squared, there's a button for that, minus 11x plus 4. Everybody found their x key? We're all good?
Good.
Okay, now, I don't remember how my window is set up, so I'm just going to try it. I'm going to hit graph. I'm actually just on a normal window. We'll see if we can see things fairly well. It's not bad. So what I'm looking at is, this is the graph of a cubic. It kind of makes this weird S shape. If you can imagine, it's on its side and flipped. But anyway, it's going through the x-axis in 3 places. So there's x-intercepts are where your roots are. It's not hitting on grid lines, which means 1 and 2 and 4 are not going to be it. So these were my possible roots. But if I'm doing the actual zeros down here, I'm not going to consider 1, 2, or 4, or -1, or -2, or -4. These are what I'm looking at. So you can do this however you want. I'd probably start over here on the left-hand side. There's something between -1 and -2. Well, the only thing we have that would fit that is 4/3, because that'd be 1 1/3, so that looks like it's probably -1 1/3, and I'll show you how to check these here in a second. Well, or I could just call it -4/3, I guess. That's going to be easier anyway. Here, I'll put in parentheses -1 and 1/3. And then this one over here between 0 and 1, does that look like a 1/3 or a 2/3?
It's 1/3.
Looks like a 1/3. And then this one over here is between 2, it's between 2 and 3. Did we have anything like that?
No, it comes out 2.56 though, calculated.
Oh, so it's possible, if this doesn't fit any of these, that this is an irrational one, which would be the square root of something that you could birthday cake. And so we may not worry about that one. There's 3 real zeros. These are probably the only 2 that are rational. So what we ought to do is check and make sure that these are actually not actually going to work too. So the way that we can check, you can hit your trace key, and while you're in trace mode, you can enter in any x, and if you want the y to be 0. That's why they call it zeros. And if they didn't work, we'll take some of these off. So let's try -4/3. I'm just going to -4 divided by 3. Make sure you use the negative key, not the minus key. Oh, and guess what? That's not a 0. I was guessing that it was, but it's not. So the calculator helps us there. So what that means is this one over here, if we trace down to it, it's probably going to be something irrational as well.
1.56.
So, but it goes on and on and on. So it's probably the square root of something. And we'll learn about how to do those in the next lesson. And so let's try the 1/3. So I'm still in trace mode. 1 divided by 3. That one does give me a 0. And so that one worked. So it looks like maybe this one was -1 1/3, -4/3, but it wasn't. So this just helps us narrow it down. So imagine doing synthetic division on possibly 12 of these numbers and finding out only one of them is a rational root. So a rational root means I can write it as a fraction that doesn't have any radicals or i's or anything like that in it. So we're just getting things that are rational right now. Okay, and so we have our list, and you could actually sit and check all of these in the trace mode. 1, -1, 2, -2. And that'd just be a very straightforward way to get through these. Okay, so let's move on to number 7. So we're going to look at possible roots or zeros. Same thing. Shh, guys, we're recording. You don't want talking in the lesson to be recorded for your parents that I could send a link to. So possible roots or zeros would be plus or minus factors of 20, which is this number on the end, over factors of, there's no number on that first term, so that's going to be 1. Okay, so the factors of 20, factors of 20 are basically 1, 2, 4, 5, 10, 20. Did I miss anything? And then they're all going to be over 1. So I'm just going to put a plus or minus in front of each of these. And because they're all whole numbers, it should be pretty easy to see. So this was my possibles, which is the first answer I have to give. And now I'm going to give the actual zeros, just the rational zeros. So the rat zeros. The rat zeros. It just sounds fun to say. Okay. So we're going to go over and, oh, I guess I got out. I'm going to go back to my y equals menu and put in this function. So x cubed plus 6x minus 20. So your x keys right here to do powers, using the caret over here. All right, hit the graph key and see if any of them are falling directly on the grid line. And it's possible we're not seeing this whole graph because 20 is kind of small. So what we might want to do is zoom out. So a quick way to do that, you can hit zoom. You can hit zoom and actually do number 3, which just says zoom out. Now you're going to go, but it didn't zoom out. It wants to know where you want the center to be when it zooms out. So I'm actually just going to leave it there on the origin and hit enter. It'll just zoom out in general that way. And we're still only seeing it crossing at one point, so maybe that's it. And that looks like it was at 2. I'm going to zoom back in.
Yeah.
And let it regraph. So it looks like 2 is there. So to check, you hit your trace key and push 2, enter. And if it comes out 0, then 2 is the only one. Now, this is a cubic function, which means there's technically 3 zeros. But if there's only one place where it crosses, that means this one's the only one that doesn't have i's in it. It's the only real answer. Okay, so we're going to do one more together.
Is there going to be a worksheet?
Yes. Okay, so let's look at the next one. So if we're looking at the possible rational roots. So these are only the possible rational ones. It doesn't take into account anything with square roots or i's in it. So we're going to have plus or minus the factors of 6 over the factors of 2. So we use the last number on top, the first number on the bottom. So factors of 6 are 1, 2, 3, 6. Factors of 2 are just 1 and 2. I keep putting commas before the numbers. Okay, so you just kind of go through. So I'm going to have plus or minus 1 over 1 is 1. 2 over 1 is 2. 3 over 1 is 3. 6 over 1 is 6. So I just did all of the factors of 6 over 1. Then I go back and do it over 2. So I'm going to have plus or minus 1 over 2. And then I do plus or minus 2 over 2, but isn't that 1? So I can skip that one. And then plus or minus 3 over 2 I don't have. And then plus or minus 6 over 2 would be 3. So this is all of my possible rational roots, possible answers to this equation that don't have i's in them or radicals. And so we're going to graph it and just see. So 2x to the third plus 27x squared plus 40x plus 6. Oh, I just did all of that in the power. Oops. I wasn't paying attention. Plus 27x squared plus 40x plus 6. I'll give you a bad review. All right. All right, so I'm seeing a couple of places where it crosses, but chances are if we're seeing 2 places where it crosses that there's probably a third. So that's looking like 0 and maybe -3/2. So instead of doing zoom out, I'm going to go into the window. I don't want to change the x-axis at all. I just want this to go further. So I'm going to hit window and go down to my y minimum and make it negative, I don't know, we'll try -25 and the max 25. So I'm just changing the y min and the y max in my window. And then I'm going to hit graph again and just see if I can see a little bit more of it.
No.
Can you see more if you zoom out?
No.
If you can't, then maybe there's just not any more. But usually if there's an imaginary root, there's 2 of them. Oh, there we go. There are 3.
Your X, yeah.
So I changed my x that time, and now I'm seeing 3. So, but this number over here is way bigger. It's I should say way smaller than -6. So it's going to be irrational. I'm not even going to worry about that. Let's try. Actually, 0 isn't on our list either. So what would that one be? -3/2. Let's try that. Trace -3/2. And I think that's the only one that's actually going to be. So my rational zeros, there's only one, -3/2, which would be the same thing as -1.5. And then I'm looking at it, and I don't see anything else on my list. 1, 2, 3, 6, half that even comes close. You are welcome to go through and check every single number if you want to.
No.
But I'm using the graph to narrow this down and to make it a little bit faster.